I will talk in this video about the special products of polynomials, or in other words, the so-called remarkable identities. So these 7 formulas, you can use them as shortcuts for multiplications of polynomials or for special multiplications of polynomials. However, you can still do the actual multiplication. For example, a plus b squared, you can think of it as a plus b times a plus b, and you do the actual distribution as I explained in a previous video. Similarly, for a plus b cubed, you can think of it as a plus b times a plus b, again times a plus b, and here you have to multiply the first 2 factors, and then the answer you distributed over the third factor. But of course, this is a lot of time, a lot of work, so it is worth it to learn these shortcuts because they will save a lot of time for you. In the first formula, you have a plus b to the power of 2. So it is a squared plus 2ab plus b squared. As an example, if you have x plus 5 squared, the x will act as a and 5 will act as b. So that is equal to a squared, which is x to the power of 2, plus 2 times the first term times the second term, so 2 times x times 5, plus b to the power of 2, and that is 5 to the power of 2. Now x to the power of 2 is simply x squared. 2 times x is 2x, and 2x times 5, that is 10x, plus, and 5 squared is 25. What if I have a minus b squared? Same story, the only difference is that the first sign is minus. For example, 2x will be our a, and 7y will be our b. So that is equal to a squared, that is 2x all squared, minus 2 times the first term, a, which is 2x, times the second term, b, which is 7y, plus b squared, that is 7y all squared. And please make sure to add the parentheses, because if I write 2x to the power of 2 like that, this means that the square is only going to act on x. However, I want it to act on both terms, so please do not forget the parentheses. Okay, so 2x to the power of 2, 2 to the power of 2 is 4, and x to the power of 2 is x squared. For the second term, 2 times 2 is 4, and 4 times 7, that is a 28. And x times y is simply xy. Finally, 7 squared, that is a 49, and y squared is simply y to the power of 2. Now, what if I have a plus b into a minus b? That is a difference of 2 squares, as you can see, a squared minus b squared. So the first term in the first factor must match with the first term in the second factor. And the second term in the second factor must also match with the second term in the second factor. And this is the case in our example. So 3m squared is a. We also have 3m squared here. And 8n is b, as well as 8n here, which is another b. And you have opposite signs. One is a minus and one is plus. That is beautiful. Everything is good. So we can apply the formula. So it is a squared minus b squared. And again, the square has to act on everything inside the parentheses. So 3 squared is 9, and m squared squared, that is m to the power of 4, and 8 squared, that is a 64, and n squared is n to the power of 2. What if I have a plus b cubed? So it is a cubed plus 3a squared b plus 3ab squared plus b cubed. So let's do an example. So here we have 3x will be our a, and 1 is going to be our b, which means a to the power of 3 plus 3 times a squared times b, so it is 1, Same, plus 3a times b squared. So in the second term, the square will act on the a, and in the third term, the square will act on b. And finally, we have b cubed. Let's simplify. So 3 to the power of 3, that is a 27, and x cubed plus. Here I have to first apply the square, so 3 squared is 9, and x to the power of 2. 3 times 9 is 27, times 1, it remains 27, and x squared becomes simply x to the power of 2. Let's continue, plus 1 squared is simply 1, and 3 times 3 is 9, times 1, that is also 9, and x remains x. 1 cubed is finally 1. What if I have a minus b cubed? So it's the same formula as a plus b cubed. The only difference is that the signs here are alternating. So as you can see, in a plus b cubed, the first sign was plus, now it becomes minus. And the last sign was plus, now it becomes minus. So same thing, just the signs alternate, and this is a worked out example. Let us move on to the difference of two cubes. So if I have a minus b into a squared plus ab plus b squared, that is a cubed minus b cubed. So we should notice that whatever you have here, you must have its square here because you have a and a squared. Similarly, here we have b, and here we have b squared. And in the middle, you have a times b. So let us see if these conditions are satisfied. So this is supposed to be our a, and that's supposed to be our b. Which means 4x squared must be a squared because of the formula. Is it a squared? Let's see. Yes, it is, because 4x squared is simply 2x all to the power of 2, and yes, it is a squared. Similarly, for the last term, that is 7 squared, which is b to the power of 2. Is it a times b? Yes, it is, because it is 2x times 7, which is a times b. So this condition is also satisfied. Last, we have to check that the signs are the same as the formula, which are. Everything is good, so let us apply the formula. So that is a cubed, so 2x cubed, minus b cubed, which is 7 to the power of 3. And simply it becomes 8x cubed minus 7 cubed, that is a 343. What if you have a plus b into a squared minus ab plus b squared? I will end up with a sum of two cubes. Let us compare it with the difference of two cubes. So again, it's just the difference of signs. So in the first formula, it was a minus, now it is plus. So in the first formula, the sign in the first factor was a minus, now it becomes plus. And the first sign in the second factor was plus, now it becomes minus. And the second sign here is always plus. And this is also a worked out example. So this is a sum of two cubes, as you can see. However, we do not have a sum of two squares. We do not have a special formula which ends up with a sum of two squares. We only have a difference of two squares.